Okay, so we're now recording. So no one say anything bad, including me. I don't think any of us say anything bad anyhow, so that's right. So first problem, we're going to take a look at this. The square root sign is supposed to go over both the 1 minus x. So just for good sense, when you're doing this type of problem, you want the x to come first. So factor anything out that might have gotten goofed up. Let's see, Alex. Let's see. Come on, go here. Go on to our Schoology page, and in the folder, you will find the link. Okay, so basically you want the x to come first. So on this problem, I'm going to do this. I'm going to have a negative out front, and I'm going to rearrange the 1 minus x. So that becomes x minus 1 plus 4. Okay, so that's kind of a good starting point with these types of problems. Make sure that you have the x first. It's not a negative x. If it's negative x, then go through it. That'll help as we go along. But they already have this graphed, and we talked about this the other day. We have a starting point right here, and this graph will continue to go forever in that direction. Okay, and then they talk about why does the domain values for -3 work? Well, -3 is here, and then -4 is here. So we have those values that are there. Into Schoology. So that's why these two values do indeed work. But if I look at +3 is here. Well, our graph doesn't exist there, and at 4, it doesn't exist. There's no graph that's up here for it to work. So it means our domain and our range are both restricted on this type of thing, which is fine. It's called a discontinuous function because the domain won't go forever to negative to positive infinity. Okay, we have to have a dot there. So we have a break. The function is also discontinuous in the range because, again, in the vertical direction, it's not continuing to go. So that's our whole idea of continuous and discontinuous. What conjecture can we make about the role of the endpoints of the domain and range? It becomes a starting point or an ending point, depending upon how you want to clarify it. I think starting and ending points mean the same thing in math, because in math, we don't have to go from the left to the right. We can go from the right to the left. It doesn't really matter. All right, so first problem. So this problem is not related to the bottom problem, but we just want to go through it and do the work for it. So I have 8 times 4. 8 times 4 is 32 over 6. And then I have x to the 4th. That becomes nothing's going to do there. So 4 plus 0 is 4. And then I have this would move up. So that's going to give me x to the 6th on top. And then this one wanted to move down. This one wanted to move down, or move up. So I could change that to a 4. I could change that to a 2. There's no longer a negative subscript because I moved directions with it. So I get y to the 7th on top, y to the 2nd on bottom. Tug of war, top wins by 5. So our problem, then I can reduce it. So let's see, 2 goes into both top and bottom. So I get 16x to the 6th, y to the 5th over 3. And the problem is done there. Okay, so let's talk about this parent function of this graph. So I know we talked about imaginary numbers before, but this graph over here is not doesn't include the imaginary numbers. It's a real number line and a real number line to make the Cartesian plane. So I can plug 0 in. If I plug 0 in, I get 0, 0. If I plugged 1 in, square root of 1 is 1. If I plug 4 in, square root of 4 is 2. If I plug 9 in, square root of that is 3. So this graph looks like this. So right here, we do have a starting point or an end point. So that does kind of, you look at, how our domain would take place. Well, it does start at 0 and it goes to positive infinity. My range goes from 0 to positive infinity as well. Okay. And then we come down here and we talk about, we have this big old function. We have A's, B's, H's, K's. We even have an X in there. So the absolute value of A is called a vertical stretch or shrink. So vertical stretch or shrink. And again, these notes will also be posted on, the filled out version of notes will also be posted on Schoology for us. So if you don't get everything written down, you're probably going to be fine. So if A is a negative value, then you have a vertical reflection. Okay, so it means it flips it upside down. The K represents, did the graph move up or down? Okay, if it's positive, it moves up. If it's negative, it moves down. And then if B, so this is kind of where we start talking about why do we want our X to be alone? You want that to be alone because the absolute value B is a horizontal stretch or shrink. Okay, and it's by a factor of 1 over the absolute value of B. If the B value is negative, you have a horizontal reflection, means it's going to go from pointing to the right to pointing to the left, and H represents the horizontal shift to the right or to the left. So if H is negative, it shifts right. If H is positive, it shifts left. So it's opposite because it's grouped. Still have some people coming in. Okay. And again, this is all recorded. It'll be on there to go and take a look at. So next problem, this top problem has nothing to do with the bottom problem, so we're just going to work it out. This would mean the X is going to move downstairs, tug of war. So I'm going to get an X in the denominator because X to the second over X to the third, the bottom wins. This Y to the fifth is going to stay up top. Y to the fifth. And 3 times 4 is 12. So 12 y to the fifth over x is how that one would work. All right, so now we want to graph the following function. So let's take care of the shifts first. So this is going to go right 2. This is going to go up 3. Okay, normally I'd started at 0, 0, but because I'm going right 2 and up 3, this graph is going to kind of look like this. Okay, so now our domain and range have changed a little bit. This is my starting point for it. My domain on this problem would start at 2 and go to infinity. And it's a hard bracket there because it is a starting point. Okay, we can use it. And then my range will go for in the vertical direction, starts at 3, square bracket again, hard bracket to infinity. And that problem is for the most part done. I don't think there's any more questions on that. And we can keep going. Any questions so far? And go ahead.
Alex Radin says that he still can't get into the meeting and that he was texting you.
I sent him a message back. I didn't see a text from him because I don't have my phone with me. Tell him to go into Schoology and find the folder for the online link, and it'll get him in.
Okay, thank you.
Thank you. Okay, very, very top problem. Holy crow, we're talking big stuff. So this x goes x to the 6th, x to the 24th times that x becomes x to the 25th power. So work from outside in. So power to power multiply. So that becomes 6. Then multiply that becomes 24. Then and then add that becomes 25. And then I would have gotten 3 to the 2, 6, 3 to the 20. 3 to the 24th power times the original 2, and 3 to the 24th power is an extraordinarily huge number. So don't try and figure it out on your calculator. Your calculator would give you an answer, something with an E in it, which is scientific notation. Don't worry about that. Okay, so next problem, a few things to think about. Okay, this is going to go down 3. Okay. This negative here flips it over the x-axis. So rather than going up, it goes down. So I'm going to go down 3, which is fine. Here's my starting point here. But it's going to flip it over the x-axis. So this point here, because that -3 was fine, but now we're going to flip over the x-axis. So it's going to come up to here. And our graph is going to go upside down like this. Okay, so yes, this -3 did account for this -3, but because this negative here, we're going to take whatever was down below and put it up above, and what was up above will flip down below. So it flips upside down. The domain of this one will go from 0 to infinity, and my range is going to be a little different because this arrow is still growing down this way. It's going to come from -infinity, and it's going to come up to 3. So it looks a little backwards. It flips over a little bit. Sometimes it's a little harder to see on rational functions when it flips over, but it should work. Anyone else coming in? And then let's see. That's all that's on that problem. All right, top problem. X to the third, x to the fourth. We add the exponents. -3 times 5 is -15. So that problem's done there. That had nothing to do with the bottom problem. So bottom problem, this is going to go left 4. This is going to go down 3. This 2 is going to just stretch it. So we're not there yet. So I'm going to go left 4 and down 3. So here's my starting point. But basically, this is going to be a little bit taller function. Okay, it grows by a factor of 2. If that 2 wasn't there, this function would look more like this. So it looks kind of the same. So the green would be if we didn't have the 2 out front. The red takes place when we have that 2 out front. So it stretches a little bit. You could do a table. It's not the most pivotal thing for you to do, which is fine. The domain of this one, being that we're going to look at our starting point right here, it's going to start at -4, hard bracket to infinity. My range is going to go from -3 to infinity. And that's what's taking place there. Okay. I think I've answered all the questions there. All right, top problem has nothing to do with the bottom problem. So power to power, you multiply the exponents, so you get a to the 12th, but then you get 2 to the 4th. Usually when you have 2 to the 4th, you could do that. So 2 to the 4th is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. So this would be 16a to the 12th. Basically, when should you make it a number and when should you leave it as an exponent when the number is raised to a power? When you realize your power is going to make it grow way too big. So if you had like 5 to the 7th power, leave it 5 to the 7th. Don't go 5 times 5 because it's going to outgrow your calculator's screen real quick. All right, so this problem. So let me do this. I'm going to graph the parent function real quick. This is what the parent function is going to look like. I'm going to call that the parent function. So let's see what's going to happen to this parent function. So that the parent function, remember, is just this square root x. Okay, that's the parent function. So let's see what's going to happen with this problem. Okay, this is going to go right 1. This is going to go up 4. This is going to flip over x-axis. This is going to stretch it by a factor of 2. Factor of 2. Okay, so let's do our shifting first. Okay, so I'm going to take this point. I'm going to go right 1, and I'm going to go up 4, and I'm going to stop there for a second. It now flips it over the x-axis. So this positive 4 comes down to this negative 4 down here. Okay, so it flips it over. Okay, it's also going to make the graph, rather than grow upward, it's going to make it grow downward. Okay, so technically this point here, if we think about what this point's doing right here, that's going to help us a lot. Okay, that point, I'm going to go right 1, up 4, flip that over the x-axis. So it goes from 5 in the y direction to -5, and it comes down here. Okay, but I'm going to multiply it by a factor of 2. Okay, so it's going to grow twice as fast. So technically it comes to right here. So now here's our graph goes upside down. This was our starting point. So our domain of this one will go from 1 to infinity. That's supposed to be infinity. Our range goes from, because our arrow is still going downward, goes from negative infinity up to -4. And a hard bracket on both of those. Still not seeing anyone that jumped in. Okay, so let's just pause there for a sec. Calling Alex. Alex, go on to Schoology. Are you on our Schoology page?
Yes.
Okay, go into the folder.
So yeah, this
Click-
is the
click.
link for all classes.
So click that, and then your password's going to be math.
MATH. Join, and it says incorrect password.
Is your caps lock on or anything?
Nope.
All right, stay with us on the phone. We'll figure it out. You can flip. Hang on, if I turn that sideways, can you see my board?
Yeah.
Okay. Cool. All right. So, and this is all being recorded, Alex. So if you missed out on anything, I'll post it on, it'll be on the Schoology site here in a little bit, about an hour. Is that all right? Okay. Let's see, next slide. So very top problem has nothing to do with the bottom problem. So 12/3 becomes 4. Tug of war with the D's, the bottom wins by 3. That's e to the first. Tug of war with the E's, the top wins by 6. So that's that problem all worked out. Okay, what should I do with this problem before I move on to anything else? What should I do first? What did I tell you all to do? What should I do with this region? I should make it a negative. I'm going to factor a negative out, so that becomes a positive x. That positive 3 becomes a -3. Okay? If you do that first, it's going to allow you to see the shifts a lot easier. Okay? So now, again, let's draw our parent function, and our parent function is this. So again, if I were to plug in values, I would get a graph that looks like that. So that's our parent function. So let's work from that. So this is going to go right 3. This is going to go down 6. What did that negative do? Does it flip it over the x-axis or does it flip it over the y-axis? If you're all talking, I can't hear you, but I will tell you that will flip over y-axis. Okay? So let's go ahead and do that. So we're looking at this point right here. So I'm going to go right 3 with that point. I'm going to go down 6. And then I'm going to flip that over the y-axis. So it's going to go from 3, -6 to -3, -6. And it's going to make the graph go that way. Okay? So that's what this graph is going to look like. So again, here's my starting point. So if I look at the domain here, because my arrow's pointing left, it's going to come from -infinity. It's going to come all the way to the right until I get to -3. And that's a hard bracket at -3. My range on this one starts at -6. And it's going upward, even though the arrow seems to be going that way, it's still drawing in the upward direction. So it's going to go to infinity. I think that's all I have there. All right, how many more of these do I have? This is my last one. All right, so top problem. This negative flips the whole thing over. And it's still raised to the third power, but now I flip the fraction over, it no longer has a negative. So you can take care of the reducing inside. So 6/2 is 3. Tug of war with the A's, bottom wins by 1. It's raised to the third power. Then I'm going to distribute this 3 here and here. So 3 times 3 times 3 is 27. So I get 27, 8 to the third. Okay. Now here's our problem. We're going to have a flip over the X and a flip over the Y. But before I start this problem, I want to factor out the negative. And I'll put that in parentheses, so X minus 2 and then minus 6. Okay, so things that are going to take place on this problem. Let's draw our parent function first. Our parent function looks like this. So let's manipulate that parent function. Okay, so that goes right 2. That goes down 6. This flips it over the x-axis. This flips it over the y-axis. So we're going to take care of that. We're going to do the shifting first and then start flipping. So I'm going to go from this point. I'm going to go right 2, down 6, 3, 4, 5, 6. Okay. It flips it over the y-axis, so the 2 negative 6 becomes 2 positive 6, so it comes up here. And then it flips it over the y-axis, so this 2, 6 that I came to now is going to go to negative 2, 6, and that's where my starting point is going to take place. Okay? Being it flipped over the x and the y, it's going to change the direction and go this way. So that's basically what my graph is going to look like now. So this is going to be my starting point. I'm basing off, or my end point. So my domain will go from, because it's coming from the left, from negative infinity, and it'll get to negative 2. And my range is going to go from coming from the bottom. So it's coming from negative infinity, and it's going up to 6. And that's a hard bracket on each of those. Okay? Take a deep breath. I'm going to jump into the next set of notes. Any questions on these so far? Good in the hood? All right, so my next set of notes are going to be these ones. And I'll post, again, those filled out notes. I will post those on Schoology, and there'll be one video, but it's a YouTube link, so you'll be able to advance it and go back on it with no problems. It's because I'm not using the play pause it at all. Alex, can you still see the screen okay?
Yeah.
Okay. All right, so doing graphing cube roots, domain and range. Okay, so this is just our normal parent function. We've dealt with this already. It looks like this. So the domain of this one goes from 0 to infinity. Our range goes from 0 to infinity. Again, they're hard brackets on the zeros because we have a starting point. Okay, so that's the first thing. We've already dealt with that. There's nothing else there. Let's go to the next slide. All right, now we have a third root. Okay, this is a third root. So this kind of graph continues. It goes forever. And the reason it goes forever is I can have the third root of a negative number. So the third root of, say, negative 8 is negative 2. The third root of 8 is positive 2. Okay, so this is going to be a continuous function. When this is an odd root, it becomes continuous. It goes forever. Okay, it's kind of like this kind of graph, like that, or it goes like that. There's my dancing for you all for today. So the domain of this one, if I were to graph this, 0, 0 would work if I plug 1 in. If I plug negative 1 in. If I plug 8 in, I'd get 2. If I plug negative 8 in, I'd get negative 2. So this is what the parent function would look like. Okay, with that known, my domain will go from negative to positive infinity. My range will also go from negative to positive infinity. Even though it kind of looks like it's going to become a horizontal as I go to the right and to the left. Hey friends, let me ask you this. Oh, are we okay? Did this screen show up?
No.
It didn't? Okay. Sorry about that. I'm gonna go here. I'm gonna go stop share, start share, go here, share. Did that show up for you, my friends?
Yeah.
Yes.
Cool. And then the one I had done just before this was that was our parent function of just square root of x. So we've already seen that one. I apologize. I didn't mean for that to happen. So again, when we have a third root, we have a little script inside the root sign, like in that little crevice in that valley. If it's an odd root, it's going to be continuous. If it's an even number, it has a starting point or an end point, depending upon how you want to do it. Now, here's kind of the rules that go with this. Okay, so we have this big old function. Notice we still have the x as a positive value, so we want to make sure we factor anything out. So if a, the absolute value of a is a vertical stretch or shrink by a factor of a. Okay, so it means it makes it taller or it grows really fast or it makes it fatter. If it's negative, there's a vertical reflection. Okay, so it means it's going to flip over the x-axis. K represents the move up and down, which is still the same. If the absolute value of b is a horizontal stretch or shrink by a factor of 1 over b, again, the 1 over absolute value of b. If b is negative, there is a horizontal reflection, which means it would flip over the y-axis. Moving on. All right, so Desmos would help you looking at some of these, but basically, oops. So this x to the third is actually x raised to the 1/3 power. This is x raised to the 1/5 power. This is y to the 1/7 power. This would be x to the 1/2 power. This would be x to the 1/4 power. This would be x to the 1/6 power. Okay, so we can write it as radical form or we could write it as exponent form, and we're going to deal with this. What shape of the odd index roots? What is the domain and range? So the shape of the odd index roots basically looks like this, and the domain and range are negative to positive infinity. What is the shape of the even? The even basically does this. Looks like that. You have a starting or an ending point. And then, you have the domain and range can either go to infinity or come from infinity, depending upon the direction of our graph. All right, so first thing I want to do is I want to graph the parent function. The parent function of this is x to the third. Okay, x to the third looks like this. That's my parent function. Okay, so let's modify with this. So this is going to move it up 5, and this is going to stretch it in the vertical direction by a factor of 2. Okay, so I'm going to start with my 0, 0. I'm going to move that up 5. So that's where that point went. This point is going to go up 5, but it was only increased by a factor of 1 there. So now it's going to be increased by a factor of 2. This point down here would have come down to 1, but because it was that 2, it's going to come down here. Then I'm going to go over to the 8. The third root of 8 had been 2 above it. Now it's going to be 4 above it. And this one will be at 8, it'll be 4 below. It'll be 4 below, so how many was that? 1, 2, 3, 5. So that's going to go 1, 1, 2, 3, 4. So this is what this graph looks like. It should be smooth, should be any speed wobbles in there. Domain and range, positive and negative infinity on both. Range, negative to positive infinity as well. Okay, so the graph stretches, shrinks, moves vertically, horizontally. Okay. This next graph, let's draw a parent function in first. -2, -8, -2. So that's our parent function. We're going to focus on the 0 first. Okay, this is going to go right to. This negative flips over x-axis. Okay, so this 0 is going to come to right here. This 1 moves right to, but it flips it over. So this is going to come down here. This one's going to go right to and move it up here. This 2 would go right to, and I'm going to flip it over. This at the -8 is going to go right to, and it's going to flip it over. 1, 2. Let's see, flip it over. So it's going to come here. So here's our graph. So domain and range of the red is still negative to positive infinity. And the range is also negative to positive infinity. Okay, so that one, it's got a little bit different. So the blue is the original. The red is where all of the translations and reflections and all the other fun stuff took place. Okay. All right, graph the following. Okay, so let's graph our parent function like we've been doing. Third root of x. So this is what my parent function looks like. And again, I'm going to look at the 0. And we're going to take care of some things. Okay, so this is going to go up 3. This is going to flip over the y-axis. Okay, so that 0 is going to go up 3, flips over the axis. Well, it's already on the axis, so you can't do it. This point here is going to go up 3, flip it over here. This is going to go up 3, flip it over here. This is going to go up 3, and it's going to flip over. So that goes up to 5, so it's going to come down to up 3. And we're going to flip that over to here. 8. And then this point here is going to go up 3. And it's going to flip over to here. That's basically what my new function looks like. Again, the domain and range, negative to positive infinity on that. So the black one is what the new equation should look like. Moving on. All kinds of fun things. First thing I do, graph the parent function. And I graph the parent function because I think it's easier. And there's not some of the teachers that don't always do that. It makes it easier for me to see. Perhaps it makes it easier for you. Some of you might be sitting there going, I still don't know what the heck you're doing, but that is what it is. Well, happy to answer questions about this on Monday as well. All right, so first thing, this is down 4. This is left 2. And this is going to have a horizontal stretch, if I could spell, stretch by a factor of 1 over 1/2. And 1 over 1/2 is like saying 1 over 1 over 1/2. So it's going to have a horizontal stretch of 2. So this 2 here means I'm going to multiply my x values by 2. All right, so let me go real slow on this one. So I'm going to find my 0 first. Okay, I'm going left 2, and I'm going down 4. So that's what took place there. Nothing's taken place with that original point at this point yet. Okay. Now, what's going to happen is, notice the distance here is 1. That distance there now will become a horizontal distance of 2. We'll take care of that in a moment. Okay, so this point here, I'm going to go left 2, down 4. It was a distance of that, so I'm going to double the distance it is from here. So it was a horizontal distance of 1. Now it's going to be a horizontal distance of 2. This same one does the same thing. It came down here, but it moves over 1 more. And I can't really do that stretch with these because I would be going out, much further on my axis. So this kind of stretches it out. It makes it a little more of a smooth. It's this fraction here, if that was like, say, 1 over 1,000, my red line would almost look like a straight line because things are stretching out horizontally. Okay, so my domain and range of this, they still stay the negative to positive infinity. That's the nice thing when you're dealing with the odd roots, is the domain and range don't get modified at all. They stay the same. All right, so given the parent function, third root, and g is square root, describe the transformation. Okay, so if we're looking at my f, so this flips over x-axis, and it goes right 4. Okay. For this next problem, for the g right here, I'm going to change this to negative x minus 1, like that. So this is going to go right 1, flip over the y-axis. This one here goes up 2, flip over the y. This one here goes up 3, and that 0.5x is going to be 0.5, same thing as 1/2. So that's going to be by a factor of 2. So this is a a horizontal stretch by 2. Means you're going to multiply all of your x values by a factor of 2. All right, this 3 sitting out in front here is going to be I have to sneeze. It's not there. Pardon me. So I'm going to go 1 over 3. So this is going to be a horizontal shrink of 1/3. That means that my horizontal distances from the 0 to the 1 would go from 0 to 1/3 in the horizontal direction. So it's making it a fatter graph. It's actually seems to be pushing it together. Sometimes a horizontal shrink actually looks like a vertical stretch, but they're 2 different things. But that's what they're saying. And then this last one, this goes down 6. This goes right 5. This negative out here flips over the x-axis. Okay? I think that's it. Yes, that's it. All right, so holy moly guacamole. I went through 2 huge lessons pretty quickly. Okay, so I will save this video as a link on Schoology. I will have the filled out version of the notes I did as well on Schoology. And then also on Schoology, are the 2 pages in which I want you to give your best shot getting the odds done. Do me a favor though, my friends. I don't want to overwhelm you with the homework. If you spend more than 45 minutes between the 2 homework pages, stop at that point. If you can tell me on Monday, I gave it an honest 45 minutes between the 2, so 22 and a half minutes per page. Don't go beyond that. Please don't come to me on Monday saying it took me like 3 hours to do my homework. Please don't do that. I will give you full points if you can guarantee that you gave me 45 minutes of honest work. Does that sound like a deal? Y'all there?
Yep.
Okay. Alex, you good with that?
Yeah.
So here's Alex. He's here. See, he's here. He really is. So Alex, hopefully we can figure out the debacle on the Schoology. I don't know what happened with that. I'm not
Yeah,
sure.
that was weird.
Which browser are you using by chance?
Chrome.
Can you switch that to Firefox or Safari?
I can switch to Safari.
Safari might work better. Sometimes Chrome sometimes gets a little goofy, and I don't know why. I'm not that computer expert. Isabella, you made it in here, right?
Yeah, it took me a few tries. I had to like just close my computer and like just shut it down and then reopen it in order to get into the class.
I got you.
So-
Okay, I'm sorry about that. How are you feeling, my
That's
friend?
okay. I'm feeling okay. You got my mom's email, right? About like everything that's going on with like the surgery and all that.
Yeah. Will you be able to do
Yeah.
stairs okay?
Oh, right.
I,
Safari worked.
I got you in, Alex. I'm hanging up on you in here. I'm sorry, Isabella, say that one more time. Are you able to do the stairs or no?
Well, right now I was able to like go up the stairs once, but like I had to just kind of like sit down and push myself up. But by the time I'm going back to school, because I won't be going back to school for maybe 2 or 3 weeks, until I can like comfortably get around,
Okay.
I should be able to do it. We'll see.
Okay. So what I will do for you, if you would like, I will have this Zoom on during our class. So you are welcome to join us live if you would like to do that from home on the Zoom link while students are here. But I will also have it recorded. So I'm going to leave that up to you, whatever your preference is. And I can't say what's the better preference one way or the other. Does that make sense?
Yeah, that's very helpful. Thank you.
Oh, happy to help you out. And that goes for any of you. If you ever miss my lesson for whatever reason, I will have these videos recorded, usually using the Zoom link. But I just want to make sure that you are able to see the videos once they're done. Being that this is close to an hour-long video, it's going to take me about 20 minutes to compress it and get it on YouTube and link it. So it'll probably be up by about noon today. Would one of you do me a favor, if you think about it, by about noon today, will you log on and make sure the video link works and just send me a text or an email saying it worked, please? All right, friends, we're at 10:50. Have a great day. Take care of one another. Talk to you real soon.